Second lesson is on the maximum and minimum values of quadratic functions. We just want to recall that to find the vertex, we need the equation in the vertex form. To get the equation in vertex form, we can complete the square. We have a maximum when the parabola opens down. So I'm just going to write that there, when the parabola opens down. So let's say you have a parabola like this, then this point is a maximum. And we have a minimum when the parabola opens up. So let's say you have a parabola like this, then this point here, when it opens up, is a minimum. We're going to try this example to find the maximum or minimum value of the y by completing the squares. This is kind of practice of what we've already done. So I'm going to leave you to try these three on your own because we have done these questions before. Just remember, for the second one here, you have to rearrange it because the a value is -3, so it's the b value then the a value. So just rearrange it before you do it. Please practice those three questions. We're going to go to an example where you have to find the maximum or minimum value of y by finding the roots and then the axis of symmetry next. Okay, so let's try to find the roots. When you find the roots, it means to find the x-intercepts, right? So if you have it in the factored form, y is equal to ax minus r and x minus s. R and s are the roots or the x-intercepts. And so how would we go from this given form, which is a standard form, to the factored form? We could factor it if it is factorable, or we could use the quadratic formula to find the roots. So let's try and see if we can factor it. So the a value is 1, the b value is -7, and the c value is 12. So find the factors of 12 that would add to give you -7. So how about 12 is equal to -3 times -4? If you multiply that, you get 12, and if you add them, you get -7. So that works. So this is simply y is equal to x minus 3 times x minus 4. So we know that the roots are 3 and 4. 3, 0 and 4, 0 give us the x-intercepts. Okay, so once we have the roots, we can find the axis of symmetry because that's by averaging the roots. So the axis of symmetry's h value is going to be the average of the x-intercepts. So 3 plus 4 divided by 2, which is 7 divided by 2, which is 3.5. So therefore, the axis of symmetry is, x equals 3.5. So what we have here, if you were to draw a rough sketch of this parabola, is something that looks like this. You have, let's say this is 3 and this is 4. This parabola has an a value that's positive, so it opens up. It goes through these 2 points where the roots are 3 and 4. And it has an axis of symmetry at this value, which is 3.5. So let's draw this imaginary line here. X equals 3.5 is the axis of symmetry. Okay? And we found the x value of the vertex, which is 3.5. So this is 3.5. We plug it into this equation, we can find even the y value of the vertex. So we can find the vertex that way. But it says find the maximum or minimum value. So let's just do that. Let's put x equals 3.5 and we get y is equal to 3.5 minus 3 times 3.5 minus 4. So that is equal to 0.5 times -0.5. So that works out to -0.25. so that we find that this particular point, which is the y value of the vertex, is negative 0.25, right? So the minimum value is negative 0.25. And what is the vertex? They haven't asked us, but the vertex we know is 3.5 comma negative 0.25. Okay, that's the minimum value because it opens up. So you could try this example. Another example is given to you where you have to find the maximum value by finding the roots and then the axis symmetry. It's exactly the same as the previous question. Try the factoring this. If it's not factorable, you can use the quadratic formula. We're going to try some word problems, and they're going to be word problems that have to do with finding the profit. So you have to familiarize yourself with the terms that are used in these kinds of questions. So let's say you have an item that's being sold and you want to find out what is the profit function. So let X be the number of items that are sold. There is a price for each function, which is called the demand function, and it's usually denoted as P of X. The revenue function is the money that you get from selling these X items. So its revenue is function, R of X, is the number of items sold, X, times the price of each item, P of X. So that's the revenue function. There's a cost of production too, which is the C of X function. It's the cost to produce X items. And the profit that you get when you produce X items and you sell X items is the revenue minus the cost. So P of X, which is capital P, is R of X minus C of X. So the demand function, which is a price of the function, the P is lowercase, and the profit function, P, is uppercase. So just don't get confused with those two, okay? So familiarize yourself with these terms because they're going to be what you're going to use when dealing with questions where you have to maximize profit. So here you have an application question. The revenue function of a manufacturing company is given by R of X equals negative 3x squared plus 26x. The cost function is given by C of X equals 5x plus 18. R of X and C of X are in thousands of dollars and X is in hundreds of units. So find the profit function P of X. We know that the profit function P of X is equal to the revenue minus cost, so R of X minus C of X. And the R of X is negative 3x squared plus 26x minus the C of X function is given to us as 5x plus 18. So we're going to simplify after opening up brackets, 3x squared plus 26x minus 5x minus 18. And that is simplified as negative 3x squared plus 21x minus 18. So that's our profit function that's asked, okay, part A. And then says determine the break-even point. The break-even point is when you make no profit. That is, whatever revenue you got is exactly equal to how much you spent on manufacturing or producing those items. So your profit was 0. So at break-even point, profit is equal to 0. P of X equals 0. So we're going to substitute 0 here in this function and solve for X. So 0 is equal to negative 3x squared plus 21x minus 18. We can factor out negative 3 here and get x squared minus 7x plus 6. And we can factor out this as x minus 1, x minus 6. So that means if you have this negative 3 times this equals 0, that means either x minus 1 equals 0 or x minus 6 equals 0, because either of them being 0 could make this entire right side equal to 0. So if x minus 1 equals 0, that means x equals 1 or x equals 6. So that means you can reach break-even point at x value of 1. X value 1 means at 100 units because the number is given as in hundreds of units, or at 600 units. Okay, so therefore the company breaks even at 100 units and 600 units. So if it makes that many, it doesn't make any profit, that many units. Part C says, determine the maximum profit for the company. How many units must be produced to achieve maximum profit? So, you're thinking of this, this company where like you have a function, which is the profit function, and X is the number of items produced. So profit is 0 at 100 units, it's 0 at 600 units, right? So you want to find out when the maximum profit is. So this point here is your maximum profit. Okay, and how many units must be produced? So this is asking you what is the maximum profit, and it's asking you how many units must be produced to get the maximum profit. So we have the profit function in factored form. It's negative 3, x minus 1, x minus 6. The roots, or the x-intercepts in this case, are 1 and 6, as you can see from here, r and s values. Our axis of symmetry is got by averaging the roots, so 1 plus 6 divided by 2, which is 3.5. So at 3.5, so 3.5 times 100 at 3.5 times 100, which is equal to 350 units, the company gets maximum profits. Okay, so that means in our graph here, this value here is 3.5 or 350 units, because it's in hundreds of units. So 350 units, you get maximum profit. And what is the value of P of X at that? So at X equals 3.5, what is our P of X? Our P of X is P of 3.5 equals negative 3 times 3.5 minus 1 times 3.5 minus 6, and that works out to 18.75. So therefore, the maximum profits are, you got to convert it into how many are there. So profit is in thousands of dollars, so it's 18.75 times thousands, which is equal to $18,750. Okay, so those are the two things. And if you went back to the graph here, this value here, this profit, this value here is our $18,750, right? That's the maximum profit. Now I put the values in hundreds of units and thousands of dollars here, but if you were to make a sketch with the the values that they have given, so you'd have a graph like this, and this would be our 1 unit, 1 x equals 1, x equals 6. This would be our 3.5, and this would be our 18.75. This is our profit function. This is x, the number of units. Okay, and you also have, like, if you used it in the scale that in hundreds of units, right? X. This would be 100. This would be 600, right? And then our profit would be $18,750, and this would be 350. Okay, so what you want to do is the best thing is to do it, keep it like this, and only in your final answer represent it in the units. Multiply that 3.5 by 100 and 18.75 by 1,000. So we have a similar word problem. A house builder estimates that the cost of manufacturing X houses is given by the cost function C of X equals 11x plus 5x squared. where X is in thousands. The demand function or the price function is P of X equals 19 plus 4X for X in thousands of houses. Find the revenue and profit function. So find R of X and find P of X. So we know that our R of X is the number of items manufactured times the demand function P of X. Okay, so that's X times 19 plus 4X, which is equal to 4X squared plus 19X. And so, and then our profit function is the revenue minus cost, C of X. So the revenue function we just got is 4X squared plus 19X minus the cost function, which they gave us as 11X plus 5X squared. I'm going to put that in brackets and combine the like terms, and I will get this is equal to negative X squared plus 8X. Okay, so that's my profit function. Part B asks, find the maximum or minimum profit and how many houses must be sold to make this profit. So our profit function is negative X squared plus 8X. So I'm going to factor it out, negative X brackets X minus 8. So that means I can rewrite this as in the factored form of negative X minus 0 for this first factor times X minus 8. The reason I write it this way is because it's now in the factored form, where the A value is negative 1, the R value is 0, and the S value is 8. Okay, so that tells me the x-intercepts or the roots are 0 and 8. Roots or x-intercepts are 0, 0 and 8, 0. And the axis of symmetry is the average of those two. So it's 0 plus 8 divided by 2, which is 4. And what I'm doing here is, if I were to draw a rough sketch here for you to understand what's going on, you have X and you have profit. And we just found out that this function, it's negative A, so it opens down. And it has a root at 0 and a root at 8. So this is how it looks. This is our 0 and this is our 8, right? And X is the number of houses. Okay, and that's in thousands of houses, okay? So we're just writing 0 house and 8 houses, not 8 houses, actually 8,000 houses. But we're just giving those numbers as they're given to us in the question, and we'll convert that to thousands and we get the answer. So our axis of symmetry is right here at 4, at X equals 4, and we have to find the profit, right? We want to find what is this profit at X equals 4. So P of 4, which is, I'm just going to write that clearly, P of 4 is equal to negative of 4 squared plus 8 times 4, which works out to negative 16 plus 32, which is equal to 16. So now you can see what the maximum profit is and how many houses must be sold. So to maximize profits, 4,000 houses must be sold. And the profits are 16. So profits is in thousands, so its profit is $16,000. Okay. Or you can also say if 4,000 houses are sold, the builder will make a maximum profit of $16,000. Another kind of word problem is to do with the geometric shape. In this one, it's a triangle. The triangle has a base that's x centimeters, and the sum of its base and height is 16 centimeters. Determine the maximum area and dimensions for maximum area. So we have a triangle, and its base is x, and its height is, let's say, h. And says that the sum of its base and height is, so let the base be x and height be h meters, and the sum of its base and its height is equal to 16 centimeters is given to us in the question. And the area of this triangle, area of any triangle, is base times height divided by 2. So in this case, our base is x, our height is h, right, divided by 2. But we have now an expression that relates the base and the height, which means the height in this case is 16 minus x. So we're going to rewrite the area function in terms of just the base. So a of x will be x times 16 minus x divided by 2. So you have a function. In the previous step here, it's not the function because you have two variables. But when you rewrite h in terms of that relationship that they have, which this x plus h equals 16, you get a function in x, and that you can use for the area. And we can rewrite this in factored form because it is kind of in factored form. So a of x equals 1/2. X means x minus 0. And this is 16 minus x. We can take out the negative. So take out a negative and write x minus 16. So we rearrange this to write it in factored form. And we can see now that the roots are 0 and 16. So the axis of symmetry is the average of that 0 and 16. That's going to be 8. And the area at 8 is going to be negative of 8 times 16 minus 8 divided by 2. That works out to 32. So here we have what's going on here. If you were to draw a rough sketch, is a function like this, where x is the base length, this is the area function, the roots are 0 and 16, this is 8, and this is the maximum area at 32. So therefore, maximum area is 32 centimeters square, use the right units, when the base length x equals 8 centimeters, right? And when height is equal to 16 minus x, or 16 minus 8, which is 8 centimeters. So we have the answer right here for maximum area and the dimensions that give us the maximum area. We can try now these questions for homework.